right, so today we're looking at section 3.5. We want to be able to solve systems of nonlinear equations. Up to now, the systems that you have solved have involved linear equations. Now we're going to look at nonlinear. We're also going to solve quadratic equations by graphing. If we want to solve equations by graphing, we have to see where it is that the two functions are equal to each other. So to make this happen, we can write a system, or we could graph the systems, and then the x value of each solution of the system is a solution of the equation when we were to set those two equal to each other. So if we want to solve this one, we could solve it by just setting these two equal, but we can also solve it on the graphing calculator. So if you go to your graphing calculator to y equals, you can put in 1/2 x squared minus 3, and we can also put in -4 minus 2x squared. We're now going to go ahead and do a zoom 6. And we want to know where is it that these two parabolas are equal to each other. What do you think the answer is? Are they ever equal to each other? No. So therefore, this has no solution. Sometimes people say no real solution, but that's not even correct. This has no solution because we're talking about where these have a common xy coordinate, and they never do. So you need to write no solution. I want to look at this second one, because this one has a little bit of a glitch, I guess you'd say, to it. So we graph the first parabola. What's the second equation going to be? Is it a parabola? What is it? It's a line, isn't it? So I'm going to go ahead and graph this. Just hit graph. Here's the parabola. Here's the line. How many solutions does it look like we have? 1. But we really don't. If I do a second trace calculate intersection, and if I just get right about here, watch guys, I do enter, enter, enter. Here's one of my solutions, 2, 0. But there actually is another solution that's really hard to see. If I do want to see it, I can do a zoom in, push enter. I'm going to zoom in a little bit here. It's a little bit better now, but I'm going to zoom in again. So I'm going to get close to this trace. I'm going to get close over here. I'm going to do another zoom in, push enter again, because I want you to see that there are actually two solutions here. Can you see now how there's another solution right here? They are not tangent. The line is not tangent to that. So I have to do second trace calculate intersect. I have to be close to it, which I am, and I push enter, enter, enter. That other solution is 2.25, comma, 0.0625. So what I want you to see there is you have to just be very sure that you don't have more than just one solution. And that's why sometimes it's actually better to solve these by doing like x minus 2 squared equals 1/4 x minus 1/2 and solving it algebraically. If we had solved this algebraically, we would have noticed that there were actually two solutions. And we'll get into how to do this here in a minute. All right, what about this one? We have a parabola and we have a line. How many solutions are there to those two? One of the solutions is here, one is here. Find those coordinates because those are our solutions. Armin, do you have one of the solutions?
No.
Can you count the coordinates? This is over 1. There's 4, 6, 8, 10. So what's the point?
-1, -10.
Then we have another solution over here. And what is that one going to be, Armin?
210.
Good. Well, 2, -10. So those are going to be our solutions. So we can do that just by looking at the graph. Everyone should know this one. What's the solution? No solution. Okay, so not too difficult when we're looking at graphs. Let's talk about how we can solve these algebraically now. So we have the equation x squared plus y squared equals 16 and y equals -x plus 4. Do you guys know what kind of shape this is? What do you think, Emily? Oh, you were thinking of a cubic function? Yeah. What do you think, Prashi? Oh, I thought you had your hand up. Oh, okay. X squared plus y squared equals 16. Guys, if we're going to put something into our calculator, we have to have it in y equals form. It would be really challenging to get this into y equals form because I would have to do this. I would have to subtract x squared, and then I would have to take the square root. Lots of people think you can just take the square root of that and the square root of that. You cannot do that. These are terms. You would have to leave it like this, and you would have to actually put plus or minus in front of it. So to graph this function, you would have to put in y equals the square root of 16 minus x squared and y equals negative the square root of 16 minus x squared. It's really challenging to put that into the calculator. I'll go ahead and just show you, but I'm going to show you an easier way to do it too. You don't need to follow along on this one. Just kind of watch. And the calculator does not do a great job with this anyway. So I put in the positive and the negative. I'm going to do a zoom 6. Here's the way it looks. What does it look like? It almost looks like a what? Oval or an ellipse is what we're going to call it later. But it's really not. Let me go to Desmos now and show you. If I type this in, x squared plus y squared equals 16, here's what it is. So what is it really? It's a circle. It's not an ellipse. The way to make this actually look like a circle is to do a zoom square. And now it's going to look more like a circle, because that makes our pixels. See how this is a rectangular screen, so it automatically stretches it out. Regardless, you need to know this is a circle. And what is this going to be, you guys? A line. And how many ways could a circle and a line have common values? 2, what else? 1 or 0. So we should either get 2, 1, or 0 solutions for this. Here's what I'm going to do algebraically. Y is equal to this, so I'm going to substitute that in for y. So I'm going to have x squared plus negative x plus 4 has to get squared equals 16. This is x squared. When we took the quiz, a lot of people just squared this and squared that. That is incorrect. If I'm doing negative x plus 4 times negative x plus 4, we have to FOIL that out. We have to multiply this whole thing out. What's negative x times negative x? The outers give us negative 4x and the inners give us negative 4x. What is that? And then we have to do the last times the last, which is plus 16 equals 16. How do we solve this equation now? We have x squared plus x squared. What is that? 2x squared minus 8x. If I subtract 16 on both sides, what do I get? Just equals 0. How can I make this problem easier? I'm allowed to divide by 2 as long as it's an equation. So I can divide by the constant of 2. Could I also divide by x? Am I allowed to just divide by x? No, it's a variable. Can't divide by x. What can I now factor out of here? X. And then what am I left with? X minus 4, right? So now I have x equals 0 or x equals what? 4. I get 2 points there. So one is going to be 0 comma something. My other x is 4. How do I find the y values that go along with these two x values that I can get? Plug them in. So negative 0 plus 4 is 4. Plug in 4 now. Negative 4 plus 4 is 0. Now, those are our solutions, 0, 4, and 4, 0. I just want to show you now, what if we came down here? Does that make sense? Our solutions of 4, 0 and 0, 4, do they make sense? Yeah. So those are going to be our two solutions. All right. We're now going to look at elimination, and I'm just going to do one of these. I'm just going to do this one, number 6. Solving it by elimination. So what I'm going to do then is I'm going to add any like terms that I can, but I first want to get everything in the right form. So I'm going to get everything here set equal to 0. So I'm going to have x squared minus 7x minus y plus 12 equals 0. Let me pause for a minute and see if you understand what I did there. Can you see how this is equal to what I first started with? Okay, this one I want to get into the same kind of order. So watch, I'm going to have negative x plus y plus 4 equals 0. That's another name for this one. I want you to watch, though, how I put these together. I have my first equation. I have my second equation. Does it make sense why I lined them up this way? Because I want to have like terms, right? Plus, what's going to happen when I add a negative y and a positive y? They're going to cancel out, right? So tell me what I get then. X squared, keep going. These cancel, what? Plus 16 equals 0. Let's see if we can factor. Are there numbers that multiply to be 16 that add to be 8? Okay, so this is going to factor into double parentheses. What are the numbers that multiply to be 16? And I need to get a negative 8, so what do the signs need to be? Both need to be minus. So what is the only x value that's a solution then? 4. So I know 4 is a solution. I now need to find somewhere to plug in to find out what y is. So I'm just going to plug in right here. So I would have negative 4 plus y has to equal negative 4. And so what is y going to have to equal? 0. So that's the kind of thinking that we have to do. For this problem, I would not use elimination. I would actually use substitution. Do you see how we have y equals this and y equals that? So what do we do with this and that? Set them equal to each other. We're not going to do it, but that's how you would do that problem. All right, we're not going to do number 8. It's just another one where you're just kind of looking to see what method you would use, whether you should use substitution or elimination. We are going to do this last problem. The sum of two numbers is negative 5, and the sum of the squares of the two numbers is 17. What are the two numbers? Explain your reasoning just means do the problem. All right, what should we use to represent our two numbers? X and Y, right. So I'm going to say X is my first number, Y is my second number. So if the sum of the two numbers has to be -5, what does sum mean? Add. So I'm going to have to say X plus Y needs to be -5. It says the sum of the squares has to be 17. So how do I write the square of X and the square of Y and the sum of those? Good. Now we have to make a decision. Are we going to try to eliminate the X's or the Y's, or are we going to just use substitution? Substitution, it makes sense. So I will solve this for Y. What would Y be? -5 what? Minus X. I'm going to take this and substitute it in here, so it's going to get plugged in right there. So X squared stays the same. Y is going to become -5 minus X, then we have to square it, equals 17. I want you guys to go ahead, I'm going to write the X squared, figure out what this quantity squared is. This quantity right here. Ian, do you have it?
X squared plus 10x plus 25.
Okay, I agree. He just turned it around. It was -5 minus X times -5 minus X. He did the last times the last. The outers give us positive 5X, and so do the inners. And the last times the last gives us X squared. And then he chose to write it in descending order, which is always good. X squared plus X squared is 2X squared. We've got plus 10X. What are we going to get if we take the 17 over? Be 8, wouldn't it? How do I make this equation easier before I try to factor it? Divide it by 2. Now, let's see if it can be factored. Are there numbers that multiply to be 4 and add to be 5? Yep, so we can factor it. What are the numbers that multiply to be 4 and add to be 5? 4 and 1. What are the signs? Plus and plus, right? So what are my possible values for X then? Good. So that means then that my first number can be -4 or my first number can be -1. What if I plug -4 in so that I can find out what Y is? What is -5 minus -4? -1. So all it's asking me to do is to find the two numbers. So I just found that when X is -4, Y was -1, right? Is it any different if I let X be -1? Then what would Y be? -4. So I don't need to write that again. The two numbers are -4 and -1. Okay? Any questions? All right, so what are the methods we can use then to solve these? We can use what? Substitution, elimination, or graphing. Very good. All right.